Now we speak to the topic very large scale integration, technology innovations. Very large scale integration, commonly known as VLSI, represents one of the most transformative achievements in the history of electronics and communication engineering. It has revolutionized the way we design, develop and use electronic system. Today, VLSI technology forms the backbone of modern computing, communication, artificial intelligence, healthcare systems, industrial automation and space exploration. Every smartphone we use, every satellite launched and every intelligent device we rely on is powered by the remarkable innovations in VLSI technology. To understand the importance of VLSI technology, we must briefly examine its evolution. In the early stages of electronic circuits were built using discrete components such as resistor, capacitor and transistors connected manually. These systems were bulky, inefficient and prone to failure. The invention of integrated circuits marked a turning point by allowing multiple electronic components to be fabricated on a single semiconductor substrate. This breakthrough significantly reduced size, improved reliability and enhanced performance. The rapid growth of integrated circuits were guided by Moore's law, which predicted that the number of transistors on a chip would double approximately every 2 years. This principle has driven decades of innovation, enabling improvements in computing, power and efficiency. One of the most important innovations in VLSI technology is transistor scaling. Engineers have successfully reduced transistor dimensions to the nanometer scale, enabling billions of transistors to be integrated onto a single chip. This has made it possible to develop high-performance processor used in artificial intelligence, high-speed communication and advanced computing systems. However, as transistor size shrink, new challenges arise, including increased leakage current, heat generation and reduced reliability. To overcome these issues, researchers have introduced advanced transistor architectures such as FinFET and gate-all-around field effect transistor. These innovative designs provide better control over current flow, improve performance and significantly reduce power consumption. Another major breakthrough in VLSI technology is the advancement of semiconductor manufacturing processes. Modern fabrication technologies use advanced lithography techniques. This allows engineers to pack more transistors into smaller areas, improving performance while reducing energy consumption. Advanced manufacturing techniques have enabled the production of high-performance process used in smartphones, smart computers, and artificial systems. These innovations have ensured that semiconductor technology continues to evolve despite physical limitations. System on chip or SoC technology represents another revolutionary advancement in VLSI design. In traditional electronic system, processor, memory units, communication modules and input-output interface were separate components. However, SoC technology integrates all these components into a single chip, resulting in improved efficiency, reduced power consumption and lower manufacturing cost. SoCs are widely used in smartphones, wearable devices, automotive systems and embedded applications. This integration has enabled the development of compact, efficient and powerful electronic systems that support modern digital life. Artificial intelligence has also played a significant role in transforming VLSI technology. AI-driven design tools are now used to automate chip design, optimize layouts and improve performance. These tools can analyze complex design parameters and generate efficient circuit designs in a shorter time compared to traditional methods. AI accelerators, which are specialized process designed for machine learning tasks, are now widely used in autonomous vehicles, robotics and intelligent computing systems. This processor enable faster data processing and support the growing demand for artificial intelligence applications. Low power design has become a critical area of innovation in VLSI technology. With the rapid growth of portable devices such as smartphones, wearable device, efficiency is essential. Engineers use techniques such as power gating, clock gating and dynamic voltage scaling to reduce energy consumption. These techniques ensure that circuits consume over only when required, thereby improving battery life and reducing heat generation. Low power VLSI design is especially important in applications such as medical implants, wireless communication device and space systems where energy resources are limited. Three-dimensional integrated circuits, commonly known as 3D ICs, represent another significant advancement. Unlike traditional two-dimensional circuit, 3D ICs stack multiple layers of circuit vertically. This approach increases transistor density, reduces signal delay and improves overall performance. 3D integration enables faster data transfer between components and enhance system efficiency. This technology is particularly useful in high-performance computing, artificial intelligence, and memory-intensive applications. Chiplet-based design is an emerging innovation that offers flexibility and efficiency. Instead of building a single large chip, engineers design smaller modules called chiplets, which are then combined into a single package. This approach reduces manufacturing complexity, improves yield, and allows designers to mix different functional units efficiently. Chiplet architecture is widely used in modern processor and high-performance computing systems, enabling scalable and cost-effective design solutions. VLSI technology plays a vital role in communication system. Modern wireless technology such as 5G depend heavily on advanced VLSI chips for signal processing, modulation and communication. These chips enable faster data transmission, lower latency and improved connectivity. Optical communication system also rely on VLSI circuits to achieve high-speed data transfer. These innovations support the increasing demand for internet connectivity, cloud computing and global communication networks. In the healthcare sector, VLSI technology has enabled the development of compact and efficient medical devices. Wearable health monitors, implantable devices and diagnostic systems use VLSI circuits to monitor vital signs, detect abnormalities and assist in medical treatment. This device improved healthcare accessibility and enhanced patient care. VLSI based medical technology has played a crucial role in advancing modern healthcare system. Space technology also benefits significantly from VLSI innovations. Space missions require highly reliable electronic systems that can operate under extreme conditions. Advanced VLSI chips are used in satellites, navigation systems and space communication devices. These chips provide high performance, reliability and energy efficiency, ensuring the success of space missions and satellite operations. Industrial automations and robotics are there areas where VLSI technology has made a profound impact. Modern factories use VLSI based processors to control machinery, including self-driving vehicles and intelligent robots rely on VLSI circuits to improve process sensors data and make real-time decisions. This has enabled the development of intelligent and automated industrial systems. Despite these advancements, VLSI technology faces several challenges as transistor size continue to shrink. Issues such as heat dissipation, leakage current and fabrication complexity become more significant. Researchers are exploring new materials, advanced cooling techniques and innovative design approaches to address these challenges. Electronic design automation tools have also become essential for designing complex integrated circuits efficiently. Looking toward the future, VLSI technology will continue to play a crucial role in emerging fields such as quantum computing, neuromorphic computing, and advanced artificial intelligence. Future communication system, including 6G technology, will require highly efficient and powerful VLSI chips. This innovation will enable faster communication, smart devices, and more efficient computing systems. In conclusion, VLSI technology represents the foundation of modern electronics and communication system. It has enabled the development of powerful processor, intelligent device, and advanced communication system that have transformed our world. Innovations such as transistor scaling, advanced manufacturing, AI-driven design, low-power techniques, and 3D integration have significantly improved performance and efficiency. VLSI technology will continue to drive technologies progress and shape the future of computing, communication, healthcare, and space exploration. As researchers, engineers, and students, we have a great opportunity and a responsibility to contribute to the advancement of VLSI technology. Through innovation, collaboration, and continuous learning, we can develop new solutions that address global challenges and improve human life. Thank you, Honorable.